today's video will start a new unit on graphing when we're graphing systems of equations. There'll be systems of linear equations. So it's going to build on the unit that we just did. So a lot of the stuff we're going to cover, well, not a lot of it, but hopefully some of it will definitely be a review. So we're going to graphing methods, for systems of equations. Now, I will be flipping back and forth from graph paper to this lined paper. So most of our notes are going to be taken on this lined paper, and then I will be going back and forth. So you definitely want to have some graph paper. If you don't have it, just do the best that you can on some lined paper, but you will need it in the future for this unit. So first of all, we have to talk about what exactly is a system of linear equations. Well, we all know what a linear equation is, right? Because that's what we just discussed. A linear equation is a graph of a line or an equation of a line. So a system is when you have two or more equations in a two-variable form. And all they mean by in a two-variable form is that you're going to have an x and a y. So you'll have an x and a y, and that's all they mean. And we've done that before. All of our linear equations that we just did involved an x and a y. So let's look at what one looks like. So an example of a system of linear equations, first of all, they're going to be connected with this bracket. I know that sometimes we have a hard time drawing that, but just do the best that you can. And there may be times where you don't see it, but the formal way to write a system is to have that bracket there. So then let's say my first one is going to be x plus 2y equals 5. And then you may have another equation, 2x minus 3y equals 3. And this is called a linear system. Sometimes they'll have two, sometimes there could be three. Like we said in the definition, it's two or more. So we're not limited to only two equations. We could have three, we could have four, and so on and so forth. So let's look at the type of things that we'll have to do with these systems. First things, let's talk about the solution or solutions to a system. Well, the solution is going to be an ordered pair we know that's xy that satisfies each equation in the system. So let's look at an example. Okay, we have to decide if the given ordered pair is the solution. Well, how are we going to do that? Let's look at an example. Let's say we have, I'm going to label it 1 because we're going to do more than one of them. Let's say we have the system 3x minus 2y equals 11 and negative x plus 6y equals 7. And we want to know if the given pair, let's say it's 5, 2, is the solution to this system. Well, what are we going to do? It's kind of like we did when we were looking with just one linear equation and we had an ordered pair. And we asked, is it a solution? Well, we're going to pretty much do the same thing. But in this case, you have to plug it into both of the equations. So we're going to plug it into 3x minus 2y equals 11. And we're going to plug it into negative x plus 6y equals 7. So I'm going to work the one on the left. 3 times 5 minus 2 times 2 equals 11. 15 minus 4 equals 11. Well, that is true. 11 does equal 11, so that first equation worked. You cannot stop there. This ordered pair has to be the solution to both of these. So you have to go ahead and do this one also. So negative 5 plus 6 times 2 equals 7. Negative 5 plus 12 equals 7. 7 equals 7. So that is true also. So your answer to this question, is the given ordered pair a solution, would be yes. It is a solution, or you can just write yes if that's what the question is asking for. So let's look at another example real quick involving the same thing. Let's see now if our equation is negative x plus y equals negative 2 and 2x plus y equals 10, and with a given ordered pair of negative 4, negative 2. So again, we have to go through and we have to check this ordered pair with both of those equations. So I'm going to go ahead and plug it in my first one. Negative 4 plus a negative 2. So you want to be careful and go back to plugging things in parentheses, because we need to make sure that our signs are correct. We're working with a lot of negatives right here. And that equals negative 2. So let's see, a negative 4 is a positive 4, and we have minus 2 equals negative 2. Well, 4 minus 2 equals negative 2. So this is not the case. And since one does not work, then we can automatically say that no, it is not a solution. So we have to be careful. If we're proving that it is the solution, we have got to test both equations. If we're just saying it's not and one fails, then it fails for the whole system. All right, so let's look at the steps for graphing these. So steps for graphing methods. Okay, so the first step, we're going to write each equation in intercept form. And I'm going to say if needed, because sometimes you will be given equations that are already in intercept form, and that means you don't have to go that extra step and put it into that form. Number 2, we're going to graph both lines. This should be a review. We just finished a whole unit on linear equations. So graphing these should be second nature. And we have to graph them in the same coordinate plane, okay? So on the same graph. And it's going to be easier for you in this unit and if you use a straight edge. A lot of these things we need to have precision for. So it's important that you get a straight edge. I have them for you to use in the classroom, but it wouldn't hurt to have one at home that you can use. Okay, after we graph both of them, we're then going to determine the point of intersection. Right? The point of intersection is where the lines cross. And there is a fourth step that is optional. I think it's important, but I'm going to tell you that it's optional, and that is you can check your answer algebraically. Now I know there's quite a few of you that will do this, and I think that's great. And then I know there's some of you that won't, but it is a good way to see if what you have is the right answer, is what you're supposed to have. Okay, so now that we have these steps, we're going to look at a couple examples. So we're going to graph and check solution. Now I'm only going to check the solution on one, but I'm going to show you that how it's done so that you in the future can do it. And it's very similar to what we did in the beginning when we actually checked to see if an ordered pair is a solution. All right, so here we go. Here's our example. We have the equation x plus y equals -2 and 2x minus 3y equals -9. So if you look at our steps again, neither one of these are in intercept form, so I'm going to have to put them in intercept form. So x plus y equals -2. I'm going to move over my x, -x plus y. Sorry, what am I doing? Just kidding. Y equals -x minus 2. I almost thought I was putting it in standard form for a second. Okay, so that's an intercept form. We can say that our m is -1 and our b is -2. Let's look at our other equation. Okay, so I'm going to move over my 2x. And then I got to divide everything by a -3 so I can get y alone. So I have 2/3 x plus 3. So we know that we have an m, a slope of 2/3, and a b of 3, so a y-intercept from 3. So now I'm going to go ahead on the graph paper and I'm going to graph both of these. So my first one, I have a y-intercept of -2. So I'm going to go ahead to -2. And I'll put my starting point. And I have a slope of -1. So that is technically -1 over 1. So I know I'm going down 1 over 1, down 1 over 1, down 1 over 1. Excuse me. And I'm going to connect my line. That wasn't good. Let's try that again. It's very hard to do without a straight edge on the board. Okay, so that was my first equation. Now I have to go back and graph my next one. So my b is 3. 1, 2, 3. And I have a slope of 2/3, so I'm going to go up 2 over 3, up 2 over 3. And just so I can kind of go in the other direction, I'm going to go down 2 over 3, down 2 over 3, and I'm going to connect my lines the best that I can. So now if you see, we're determining the point of intersection. Well, the point that these two lines intersect is right here. And we know that that is the ordered pair -3, 1. So the solution to this system is going to be -3, 1. So I can go back. Sorry, I got to go all the way to the bottom. And now the solution or the point would be -3, 1. I could go back in and plug these into this equation that we have and check them. -3, if I did the top one, -3 plus 1 is a -2. Well, that's true. I can plug it in the bottom. 2 times a -3 is a -6. -3 times 1 is -3, and those equal -9. So I know that that point is, in fact, the solution to that system of equations. All right, let's look at 2 more. Next one's just going to be just about as easy as you can get. This is the equation y equals 5 and x equals -2. All right, we don't have to do anything. Those are linear equations, so it's definitely a system of linear equations. They're already in intercept form, so I'm going to go back to my graph paper and I'm going to see what I got. So I have y equals 5. And I have x equals -2. So right there, I know that I have the ordered pair -2, 5, which makes sense looking at the equations. So I can go back to my page and say, okay, well, the solution to this is -2, 5. All right, last one, and it's going to be the most complex that you are going to see. Let's see. So I have the system 3/4 x minus 1/4 y equals -1/2. And then I have 1/4 x minus 3/4 y equals 3/2. All right, so we got a whole lot of fractions going on here, but we know how to get rid of these fractions. We've done this before. So I'm going to go ahead and multiply everything in my system. Every single thing in the system has to be multiplied by the same thing. Okay? So I'm going to pick 4, obviously, because I got some 2's and 4, so I'm going to use 4. And I'm going to see what I got. 4, so I'm going to multiply by everything. 4 times 3/4 gives me 3x. Here I have -1/4 y times 4, that's -y. And then I have -1/2 of 4. Half of 4 is 2. 2 times 1 is -2. Okay? Do the same to my bottom. Multiply it by my x term. I get just x. -3/4 times 4 is going to give me a -3y. And then I have 6, or 3/2 times 4. 2 goes into 4 2 times, so 3 times 2 is 6. Okay, now I have something that I'm used to seeing. I have an equation, but it is in standard form, not in intercept form, so we got to keep going one step further. I got to put these in the right form. I'm going to move over my -3x. I have -y equals -3x minus 2. Divide everything by that negative, and I get y equals 3x plus 2. Same thing, I'm going to do it with my other equation. X plus 3y equals 6. I got to move over my x. Divide by 3. And I have y equals -1/3 x plus 2. So now that I have my two equations, I'm going to go back to my graph paper. I'm going to graph them. So I got my first one. Y equals 3x plus 2. I'm at 2. My slope is 3x, or 3 over 1. So I'm going up 3 over 1. And I'm going to go down 3 over 1, down 3 over 1. Okay? And draw my line. I'm going to try to draw it with this, so it makes it nice and easy. Close. Put some arrows on it. Now draw my other one. I got +2. Okay, so who saw the mistake that was made back here? We got to go back. I made a mistake and I actually caught it this time. When I copied this down here, I had a +3y when I actually need a negative. So that was my mistake. So I got to fix it now and regraph. Just give me 2 seconds. So if I have x minus 3y equals 6, I can do subtract by x, subtract by x. I get -3y equals -x plus 6. I'm dividing by a -3. So I should have y equals 1/3 x minus 2. That was my mistake. Let's look at that graph again. So now I'm actually starting. I was wondering why I wasn't getting the right graph. I'm actually starting at, so I'm not starting here anymore. I'm starting down at -2. And my slope is -1/3. So I'm going down 1 over 3. And then I can go up 1, back 3. Okay, so in a perfect world, these would have crossed kind of more in the center. And what I'm saying is we are not expecting you to know exactly where these two lines cross. So when it crosses between the two, we're just going to give an estimate. So I'm going to go up here it's supposed to cross and about there. I'm just going to call that, and we're going to go to the half. So negative 1.5 and negative 1.5. And that's close enough. On my paper, when I did it with a ruler, they kind of crossed more towards the center of that paper. So what I'm saying is we don't know exactly what that is, so we can estimate that those would be the solution to that. Okay, well, we'll practice more when I see you in class.